Hi guys, welcome to the lecture series of Gen AI. So today we will be seeing introduction to Gen AI. So in today's lecture, uh, we will be seeing applications of Gen AI and AI/ML, the small overview of artificial intelligence and machine learning, and also an overview of generative AI, and also an introduction to neural networks. So like there are so many applications of AI in our real world. Uh, there are many examples that we can relate to. So few are we are seeing AI is revolutionizing our world from autonomous vehicles to robotic surgery, and AI is everywhere in our personal and professional lives. Uh, like uh, we have also seen we have given a prompt like a game towering cloud in the shape of a man looms over the earth. The cloud man shoots lightning bolts down to the earth so that the AI will generate a photo where you can see a text given to the prompt and the image will be generated. And we have also will be seeing soon where in showrooms you will be having a virtual trial rooms where you have to just stand and the clothes will be on it. And we have also seen the fitness tech where the AI helps to maintain the uh, fitness, and also if we are doing any exercise, it will help to us to do like how we are doing it. It will track all the positions and all. And in real life, we have seen uh, activity recognition. In this picture, we are there's a camera where it captures what people are doing. We have also seen in traffic signals where it automatically takes the photo of a guy who is not wearing the helmets or while driving. So this is the applications of AI in our real life. So AI is everywhere. If we see in banking and financing, or vehicle recognition identification, uh, as I said, the camera captures the number plate of a vehicle who is not wearing a helmet. And whereas in social media, smart suggestions, where AI has a guide on social media. It watches it watches what you like and what you do, and then it suggests the thing you might enjoy, like posts, videos, or ads. It acts as someone who knows your taste and show you stuff you are really into, making your social media experience more enjoyable and professionalized, right? So, and also in healthcare, we have something like detecting health problems early, where AI acts as a healthcare detective, where it helps or looks at your health information to find out if you might get certain disease in the future. When it sees a high risk, doctor can step in early to help you to stay healthy. This is really important for conditions like diabetic and heart problems because catching them of this time means better treatment and less trouble for the patient. Right? So we have also seen reached cancer detection on so many uh, algorithms or apps being developed, where you have to just enter your past medical details like BP and all things, and it will show it will just predict whether you have it or not. And also in video games, you can have, and with navigation and travel, we in day-to-day life we use Google Maps, where in which uh, it shows the shortest route, and if there is a traffic, it will tell us showing a red color to that area, right? And in agriculture as well, with uh, uh, smart farming and efficiency, AI makes farming super efficient. It will help the farmers use just the right amount of things like fertilizers and pesticides not too much and not too little. This means there is a less waste and the crops grow better. So it can also help in monitoring the crops uh, and many more. Okay, and as well as security and surveillances like uh, camera can analyze who's coming and who's going. It can do a face recognition thing as well. Okay, so this was the all the applications of AI and ML were day to day. Let's get into the overview of AI and ML. Okay, so AI is a method that enables machines to mimic a human intelligence. So artificial is a big thing where we have many more subsets like machine learning, deep learning, and Gen AI. So machine learning is a method that helps machines to identify the hidden patterns, the data. Like example I've given before, like in a medical where understands the medical history of a patient and predict the occurrence whether you have disease this or not. Whereas deep learning, it's a branch of machine learning that uses neural network to understand the data. Like has a like it nothing but it tries to mimic the uh, neural network of human beings. Okay, how the information is being passed. Okay, so this is the AI versus ML versus deep learning. So AI is a broader term to describe the capability of machine to learn and solve problem just like human. In other words, AI refers to the replication of human, how it thinks, works, and functions. On the lower ground, AI can be seen as a program that instructs the machine to function in a certain way according to the situation. So we can call a bunch of if-else statements. AI, for instance, self-driving car, moving on the road. So there is a relation of AI with ML and DL. There are two types, two ways of incorporating intelligence in artificial intelligence. That is to achieve artificial intelligence. One is through machine learning, and another is through deep learning. So now that we have understood the term AI, we can take a closer look on a machine learning and deep learning. Machine learning comprises algorithms for accomplishing different types of tasks such as classification, regression, or clustering. The accuracy of algorithm increases with the increase in data. Analyzing and learning from data comes under the training part of the machine learning model. During the training of the model, the objective is to minimize the loss between actual and predicted value. For example, in the case of recommending items to a user, the objective is to minimize the difference between the predicted rating of an item by the model and the actual rating given by the user. Okay. So, what deep learning is an emerging field that has been in steady use since its inception in the field of 2010. It is based on an artificial neural network, which is nothing but a mimic of a working of a human brain. Just like the ML models, the deep learning model requires a large amount of data to learn and make an informed decisions, and is therefore also considered a subset of ML. This is the one of the reason for the misconception that ML and DL are the same. However, the DL model is based on artificial neural networks, which have the capability of solving tasks which ML or machine learning is unable to solve. Yeah. So we have a different types of machine learning. First is supervised machine learning, and second is unsupervised machine learning and reinforcement learning. So the supervised learning is a type of machine learning algorithm that learns the labeled data. Labeled data is a data that has been tagged with the correct answer or classification. Okay. Supervised learning, as the name indicates, has the presence for supervisor. As a teacher, supervised learning is when we teach or train the machine using the data is well labeled, which means some data is already tagged with the correct answer. After that, the machine is provided with a new set of example so that the supervised learning algorithm analyzes the training data set and produces correct outcomes from labeled data. So, for example, here we are giving a set of apples, and this is the label. These are apples, and we train it, and we give a apple as a new set, and uh, tell our model to predict it. So it says it is an apple. For example, let's take another example: a label data set of images of elephants, camels, and cow. Would have each image tagged with either elephant, camel, or cow, and then we gave that to a model. After training it, we give a new image of a camel. So the model should predict that this is camel. Okay, and next, there are two types of supervised learning, that is regression and the classification. A regression problem is used when the output variable is a real value, like a dollar or a rupee. And classification problem is when the output variable is a category like yes or no, true or false. Okay. And next is unsupervised learning. It's a type of machine learning that learns from unlabeled data. This means that the data does not have any pre-existing labels or categories. The goal of supervised learning is to discover patterns and relationships in the data without any explicit guidance. Okay. Unsupervised learning is the training of a machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without a guidance. Okay, so here is the input where we have a mixed image of apples, bananas, and uh, uh, another fruit. So we gave to that model, and it uh, it separates the different images according to the how it looks. So here you can see all the apples are separated in one group, and bananas are separated in one group. Okay. So unlike supervised learning, no teacher is provided. That means no training will be given to the machine. Therefore, the machine is restricted to find the hidden structure in unlabeled data by itself. You can use unsupervised learning to examine the animal data that has been gathered and distinguish between several groups according to the traits and actions of the animal. Okay. This grouping might correspond to various animal species, providing you to categorize the uh, creatures without depending on labels that already exist. For example, if there's a picture of a tiger and a cat is given, like you can see there is a similarities and both the images, so it will be grouping to one. Okay. And the next is reinforcement learning. Reinforcement learning is a branch of machine learning focused on making decisions to maximize the cumulative reward in a given situation. Unlike supervised learning, which relies on training a dataset with predefined answers, reinforcement learning uh, involves learning through experience. In reinforcement learning, agent learns to achieve a goal in a certain potential complex environment by perform actions and receiving feedbacks to rewards or penalties. So here is an example where there is a agent who has to fill this bucket up bucket with water and throw it on the fire. So the next time when the if it doesn't do the task, it will be getting the negative points, and it will learn from that and try to gain the maximum points. So it learns through feedback. Okay, this is reinforcement learning. And next, we will be seeing the overview of Gen AI. So nowadays, as we all know, the power of artificial intelligence is developing by day. And after the introduction of generative AI, is taking creativity to the next level. Generative AI is a subset of deep learning that is again a part of artificial intelligence. So generative AI helps to create a new artificial content or data that includes images, videos, music, or even 3D models without any effort by humans. The advancements in large language models have led to the development of generative AI. So generative AI models are trained and learn the data sets and designed within the data based on large data sets and patterns. So they can generate new examples that are similar to the training data. Okay. These models are capable of generating new content without any human instruction. In simple words, it generally involves training AI models to understand different patterns and structure within existing data and using that to generate a new original data. Okay. So there are technologies like GANs, uh, virtualization autoencoders, and transformers like GPTs. The technologies are there to implement the generative AI. So the example that a major example that would be Chat GPT. Okay, so where you can generate anything. So this is the applications of AI use cases where you can see in text. We have a PDF where I want it, which has so many pages, and I want it in a summarization. You can use Gen AI for that, or you want to mail mail someone some message in a formal way. You can ask Gen AI for that, and for you can also use for translation. You want a language translation, or you can use also use for a report and also for creating PowerPoint presentation. Whereas in code, you uh, can do coding as well. Like you can ask to generate a code for building a website or doing some task, or you can also do a text to SQL. Like I want to uh, insert this value in a table, like that. Okay. Also, you can create images as I shown before. Like we will be giving a prompt saying a cloud, which I show earlier. You can also use that for generating images, and also you can use for PowerPoint presentation where you want to attractive PPTs you want to create, like images should be there and all. So you can use Gen AI for that, and also you can use speech where you just record your voice. It either can translate to the other voice or give you something. Okay, so these are the few use cases that are there. Okay. So there are all exam applications of Gen AI in each and every domain, like healthcare. You can make a personalized treatment plans using Gen AI. In business, you can uh, generate a predictive sales. In education, students can have a very big advantages like generating the assignment or help with assignments. Or even if you don't understand a topic, if you just give it to if you want to generate or understand the depth of the topic, you can use Gen AI. Okay. Then when software developer, as I said, you can generate code, publishing media. Like if you want to gather information from web and you want to have a summarized of the topic, can use that for Gen AI. Also, you can use it in cyber security. Like if there is any threat that should be that to be detected, you can use Gen AI. Okay. So these are the common technologies: GANs, Generative Adversarial Networks, Variational Autoencoders, Transformers, and diffusion models, and many more. Okay. So, what is GANs? Generative Adversarial Network is a type of machine learning model that creates new data that is similar to an existing data and is and that is similar to an existing data. It was proposed by Lang Fellow in 2014. GAN generally involves two neural networks, that is a generator and a discriminator. Okay. It is generator and discriminator. The generator generates new data samples while the discriminator verifies the generated data. The design is influenced by idea from game theory, a branch of mathematics concerned with the strategic interaction between different entities. The two networks are trained together in a process in which the generator attempts to fool the discriminator into thinking the generator data is the real, while the discriminator attempts to accurately detect whether the data is real or fake. The process is repeated until the generator becomes so good at providing realistic data, and the discriminator can no longer distinguish the difference. GANs can be used for image synthesis, style transfer, data augmentation, and other issues. So here is an example where there is a generator who is a thief, who is creating, who is publishing a fake money, and here is a police who is the task of the police here is to find whether the given note is a fake or real. Okay, and next is large language models. So large language models are AI models just trained on vast amount of text data to understand and generate human-like language. So these are based on transformers, where encoder, decoder are there. So, for example of a large language model can be ChatGPT, where the ChatGPT is trained on vast amount of text, and you can see like how it generates the how we can chat with it. Okay. So transformers have transformed Gen AI by introducing a highly effective architecture for tasks like language translation, text generation, and even image synthesis. Okay. And also there's another technology studies diffusion models, which are the powerful class of generative models that have gained prominence of field of machine learning and artificial intelligence. They offer the unique approach of generating data by simulating the diffusion process, which is inspired by physical process such as heat diffusion. Exploring its art, diffusion models are generative models that learns to reverse the diffusion process to generate data. Okay. The diffusion process involves gradually adding noise to data until it becomes pure noise. Uh, Through this process, a simpler distribution is transformed into complex data distributions in a series of small incremental steps. Essentially, these models operates a reverse diffusion phenomena where noise is introduced to the data in a forward manner. Like you can see here is a given image X naught, and slowly it's, keep on adding the noise data to it, and here complete noise value is yeah. And so then after adding the uh, noise data by learning, it just go reverse and getting the final image or the first original image. So using this process, the model uh, learns the reverse process and brings the closely resemble picture. So this is the diffusion model. This is also known as denoising diffusion probabilistic model (DDPMs). So these are generative models that gradually or the data and learn to reverse the process, generating new data sample. Okay. So the next is introduction to neural networks. So the neural networks extract identifying features from data lacking pre-program understanding. Network components includes neurons, connections, weights, it biases, propagation function, and learning rule. Neurons receive inputs governed by thresholds and activation functions. Connections involve weights and biases regulating information transfer. Learning, adjusting weights and biases occurs in three stages: input, computation, and output generation. And iterative refinement enhancing the network proficiency in diverse tasks. This includes the neural network is simulated by a new environment. Then the free then the free parameters of neural networks are changed as a result of the simulation. The neural network then responds in a new way of the environment because of this change in the free parameters. The importance of neural networks is the ability of the neural networks to identify patterns, solve intricate puzzles, and adjust to changing surroundings is essential. Their capacity to learn from data has far-reaching effects, ranging from revisionalizing technologies like natural language processing and self-driving automobiles to automating decision-making process and increasing efficiency in numerous industries. So neural networks are a complex systems that mimic some features of a functioning of a human brains. It is composed of an layer, one or more uh, hidden layer, input layer, one or more hidden layer, and the output layer made up of layers of artificial neurons that are coupled. The two stages. So this is the neural networks or the basic neural networks for uh, first neuron that was invented were called perceptron, which has some inputs and a summation function and activation function and output. So the inputs are given and multiplied with the weights and added with some bias, and using this the output is predicted. So that later on, after this, we have created a neural network. This is also a basic network where you can see in each step we have a summation function. Also, we are adding some bias in it. So it is the input layer, and this is called a hidden layer. We can have a one or more than one hidden layer. So you can see like there are too many hidden layers here. Yeah. So that's it about it. Let's be seeing practical like how to implement neural networks in tomorrow section. Uh, that's it. Thank you. If you are new to this channel, please do subscribe and please do like the uh, video. If you have any doubts, please do comment. Thank you.